So this chapter is all about setting up proofs. As far as like this is the introductory stages, you need to know some background before we actually get into true proof writing. You probably have heard that the hardest part of geometry is proofs. It's really not as bad as what you think. This chapter will feel more like English class than it does math class, but like I said, this is a foundation introductory stuff to get to proof writing. So anyway, 2.1 is conditional statements. So a hypothesis in mathematics is an unproven statement. Sorry, I'm going to zoom in so I can write a little bit more clear. It follows the if. And it's the P. So for right now, just write that down. I know you don't know what that means, but you will in just a moment, okay? So conclusion is the result of reasoning. It follows then, and we will know it as Q. Like I said, just write this down for right now. I know that doesn't make sense, but it will. So a conditional statement is known as if P, then Q, aka if the hypothesis, then the conclusion. Now, conditional statements, all of our theorems are set up as conditional statements. All of our postulates are set up as conditional statements. So the foundation of geometry with the theorems and how they got to theorems, because remember, a theorem is a proven statement. It's all based on these conditional statements of if P, then Q. So like I said, this is a foundational to setting up your proofs. You need some common understanding here. So the converse is the switch of this. If Q, then P. An inverse, if not P, then not Q. You might also see this as if tilde P. The tilde just represents the not. But just wanted to show you both formats here. Contrapositive, if not Q, then not P. Again, you might see it with the tilde. So this is just setting up, like I said, a statement and then just rearranging it based on what you're being asked. A biconditional is actually where you take out the if and the then, because both conditional and converse must be true to exist for a biconditional, and it will be if, it won't even have an if at the beginning. It'll be P, if, and only if Q. Sometimes you will see it if and only if can also be written as if. Just something to note, you might see it that way. I have a tendency to write the if with the double F just because it's shorter. So just giving you a heads up, you can by all means write if and only if out. That's not a big deal. But in order for a biconditional, both the conditional and the converse must be true. A lot of your definitions are a biconditional statement. So, for instance, a figure is a square if and only if all sides are congruent, all angles are right. Now, if you were to switch that, if a figure has congruent sides and all right angles, then we know it's a square. So it's just thinking about those definitions. You know, you have this front part of what it is and what is it that classifies it that way. And then if you switch those two, it's not a big deal. We already know that's true as well. So that's where a biconditional, it's your definitions. So example 1, underline the hypothesis and circle the conclusion. All right. So the hypothesis comes after the if. So looking at this, an animal is a dog is my hypothesis. It has a tail is my conclusion. There's my if, P, then Q. Example 2, write the statement as a conditional. So when you're writing it as a conditional from original sentence, this is going to be a little bit on English here. You have to find the verb. The verb is going to tell you where your split is. So angles whose measure are between 90 and 180 are obtuse angles. So technically you have two verbs here with the are. But if I'm thinking about this, I have a definition because we have obtuse angles. So thinking about that, so this is my split. You have to, and when you rewrite this, you have to use a little bit of fluff to make it make sense. So if an angle whose measure is between 90 and 180, then it is obtuse. Now notice, technically speaking, I went from plural to singular, which isn't a big deal, but just kind of giving you a heads up. So look for that verb, and you have to figure out, because you can have multiple verbs, you just have to figure out which one is going to be your split. Example 3, write the converse, inverse, and contrapositive. Determine the truth value of each. If false, provide a counterexample. So we got to figure out your P and your Q. Sophomore, high school. Those are your P and Qs. So this is a conditional. Just remember that. So if you are a sophomore, then you're in high school. Now, technically, this is false because you could be a sophomore in college. So my counterexample, sophomore in college. So now converse, if you are in high school, then you are a sophomore. True or false? That's false. You could be a freshman. So when you're providing that counterexample, you just need one example to prove why that's wrong. By the way, counterexample, proving that it's wrong. Inverse, if you are not a sophomore, then you are not in high school. false freshman. And last but not least, contrapositive. If you are not in high school, then you are not a sophomore. False, because you could be a sophomore in college. If you're a sophomore in college, you're not necessarily in high school. Technically, you could be if you're dual credit, but we're not getting into those picky details. So sometimes you will have a conditional and all four of them will be false. Or sometimes you'll have all four of them are true. Sometimes you'll have two of them that are false and two of them true. I will say you won't ever have a situation where one is true and three are false. It'll either be 2 and 2 or 0 and 4 or 4 and 0. Just because if you look at like the converse and inverse, notice I use the same counter example because those two are related. The conditional and the contrapositive use the same example, counter example. They're related. So if your conditional is true, your contrapositive will also be true. If your converse is false, your inverse will also be false. So just something to note. If you're unsure of what I'm discussing there, just go through them individually and figure out your truth values. It'll be easier that way. And then, last but not least, write a biconditional for the definition. So once again, you're looking for the verb to figure out your split. A square has. That's your split. So ironic that I already kind of discussed this. Again, you'll have to add some fluff a little bit. So a figure I was going to draw a square and then I decided not to and it just did not work there. If a figure is a square, a figure is a square if and only if it has 4 right angles and 4 congruent sides. And ta-da, there's my biconditional. So there it didn't ask me to figure out if the conditional and converse were true. They're already telling me they both are. I just needed to write the biconditional. So there's our beginning of conditional statements. We'll be using those for a while. And you'll, like I said, throughout the rest of the year, or the rest of our time together, I should say, you will notice that your theorems and all of that kind of stuff, they're in conditional statements. So just giving you a heads up, we can discuss this further in